Good morning. Can you hear me? Yes. Awesome. Thank you very much for your presence here today. My name is Kleber. I'm a solutions architect in public sector in Brazil. And I'm here today with two of the most outstanding professionals that I have the pleasure to work with. Ms. Andrea Gouveia, Principal Solution Architect for Professional Services in Brazil, and Mr. Vinicius, Senior Partner Solutions Architect for Brazilian sector as well. And we are going to navigate you through the history of the Brazilian elections of the last year, 2022 Brazilian elections. Sorry. What we are going to see here today, we are going to understand what is the customer, right? And what is the election process in Brazil, where AWS fits in that, where AWS could help with that. And we are going to dive deep into two different projects, and then we are going to talk a little bit of what we achieved and what are the key takeaways that we had for that today. So first, who the customer is. Superior Electoral Court, or in Portuguese, Tribunal Superior Eleitoral, is one of the fifth Brazilian justice segments, and there is electoral, there is military, there is common justice, and the Electoral Superior Court is mostly responsible for almost 9 years from now. They are responsible for organizing and distributing all election matter in Brazil. So they organize the elections in every 2 years, and they have also implemented electronic voting since 1996. And in 2020, they reached out 100% voters using electronic voting machines. So we are expected to have around 156 million voters in Brazil. And we have several regional electoral courts as well that they help TSC pull out all the elections. And in 2022, we had the general elections. What is the general elections in Brazil? It happens in 4 years, like most of the countries. In that elections, we vote to elect president, senators, governors, and representatives at state and federal level. As I told you before, we have 156 million voters able to vote in Brazil for a 210 million population in general in Brazil. We have the support of more than 2 million poll workers, so it's citizens that are invited to help with the electoral process in Brazil. In Brazil, the elections happen in more than 5,000 cities. So you see that's a massive scale election in 27 states and 181 countries. We have Brazilians voting outside Brazil and just find their absence and other stuff. We have, as I told you, in 2020, we reached 100% of voting machines used, so there is no paper, there is no ballots, there's nothing like that. And we have something around 460,000 polling stations. So each one of us is demanded to go to a certain polling station in order to vote, and you're going to understand later why that is important. So for us to understand the overall electoral process in Brazil, we have divided it into 4 phases here. First one is the preparation, where all voters should, or must, actually, we must update our information with the electoral justice. So this is something that happens several months prior to the election day, the voting days as well. And everything is in place with the preparation, we go to the voting days. So in Brazil, we have first and second term if needed. It happens on October, usually. And after 5 p.m. in Brazil, usually we close the voting machines and all the votes are computed into TSC's infrastructure. And after everything is validated, everything is counted, then we go to the distribution phases where we have all Brazilians hitting refresh button in order to see the advance, the progress of their favorite candidates. And AWS can helped in 2 of these steps. The first one is the preparation, and the second one is the distribution phase. We are not involved directly on the voting or the voting processing or the voting computing stuff. So we had on the preparation and the distribution. And how we did that? So the first one is the official digital voter ID mobile app. It's called E-Título. And the challenge here is that TSC expected to have 100 million simultaneous users. They had an expectation as well to reach 100% availability since they had previous issues on 2018 elections. And to support that 100 million simultaneous users, we have 14,000 requests per second on the authentication service. And in 2022, TSC has created a new service in order for us. For example, I'm away from my home city, I'm away from my polling station, and then if I'm not going to vote, I can't vote in another state or another city. I must justify my absence. And how we used to do that before the 2022, we must personally go to a polling station, fill up a form, and then wait for that to be processed. So in 2022, TSC decided to put that on that mobile application, and they have other plans in order to advance on electoral services and electoral information. They are going to provide all in one single app. And the second one is the results distribution. I'm not going to be thorough for that because my brother Vinicius is going to count on you on that. But you can see there is an expectation of 500K current requests and other stuff, pretty interesting stuff that you're going to see there. And now we are going to see what is this mobile app. So I'm going to introduce you to the architecture, as what it is, and the architecture, and some challenges that we had, and then we are going to see the other project with my fellow Vinicius. So, as you can see, as I told you, E-Título is a mobile app available to almost every platform that we have. And what is it? It's a mobile app where I, like a Brazilian citizen, I can go there, I do my registration, and I gain my digital voter ID. This is the official ID that you can present when you go to your polling station. And this mobile app is gaining several different services. And as I told you, the one in 2022 that was started this year, it was the justification absence. So why TSC came up with the idea of having a digital voting ID? So we have different perspectives here. For the voters' perspective, we had several cases. I myself, I'm one of those. The ID, the paper ID, it got damaged, it got theft, it got destroyed, and we kept going into the regional courts in order to get a new one. So it implicates in less rights. So voters, especially poor people, they don't have the resources in order to be going every time that they have a problem. So it helps them get quick access into whatever information that they have for their voting places, for their communication with the electoral justice. For the financial perspective, TSC had a lot of spend using paper and office supplies and energy and build maintenance for the regional court offices. And we also had a benefit of having reduced the duplication of voting ID. That's a major problem for elections when you have two people with one single document. And this is another driver for TSC. And for environment as well, we have fuel consumption, we have carbon emissions, and we have paper usage. So everything is electronic now. We don't need to print, we don't need to send, we don't need everything like that. To implement that, what are the challenges? What do TSC faced when they reached out AWS to support them with that? So from the business side, we have 156 million voters. TSC needed as well to optimize their spend, so every year the budget is getting shorter, so optimization is needed. Better voter experience, so we had a lot of going back and forth in order just to do your absence justification and other stuff like that. And this was all cut from 0. We have expanded communication with the voter. So TSC wanted to send notifications, want to, how can I say, combat fake news as well. So by sending notifications to the voters, and everything in that has one strategic goal, is for eTitulo, the mobile app, to become the regional court. So we are going to take out the regional court and make it work inside the application. And for technology as well, as we are going to see, they do not have a lot of technology gaps, technology issues. They work on a monolith application. They had issues before with the massive scale as well, and they wanted to do everything with security because we had a very harsh political against the elections in Brazil, and they had worries about the business continuity as well. Just for you to understand how everything went out, we had this timeline. Everything started in July, and we had until the 15th of September to go live. So we had a 71 day to architecture, build, and test everything else. And during October, we had the first and the second term. At this time, eTitulo backend was running on AWS, and when we reached mid-November, we had to roll back. So it's an interesting characteristic of this application. Once the voting is done and the results are published, most of the users, they delete the app from their cell phone. So TSC had no intentions of letting the application running on AWS. They just brought it back to their on-premise side. So a little bit of the technical background. Just for you to understand, they had two different services. They had application services and they had authentication services. And it's a regular mobile application. They use database, they use queues, they use file shares, they use indexes in Elasticsearch, and they have several different databases for us. And how does it turn out in AWS, on AWS? So we have this reference architecture. And as you can see, we have changed a lot of technologies here. There are 17 different versions of this architecture, since my fellow Andrea is going to explain you our testing methodology. So we have here all the edge technology for AWS, and you're going to understand why we use CloudFront and API Gateway in order to be the edge of this application. We have kept the authentication service running on EC2. And then we bring all their Docker images and we decompose their application to 7 different services using ECS with Fargate. And then we have also used serverless services in order to use the queues, object storage, and key value that database. So they had an on-premise relational database, and we transformed it to run with DynamoDB on AWS, and all other services related to security and operation as well. This architecture has its own challenges. Just for you to understand, we have the first one here is the data migration and rollback. We had a large amount of data. We had 90 terabytes of data, billions of registries that we should bring to AWS and then roll back into TSC's infrastructure. We are going to see that in detail. The number two issues and challenge that we had is related with DynamoDB scaling. The third one, disaster recover, as you may be thinking about, and the other stuff are related with limits with network load balancing, application load balancing, API gateway. All of these services were tested in depth, and all of them performed very well, but you're going to understand why we did that. So the first one, the data migration, TSC hosts all of the information on their side, on their on-premise data center, and then we have a data preparation task that extracts all the information from the internal systems and then places it into an index. This index is read by a Logstash EC2 fleet on AWS, and then we split that into 6 different indexes, 6 different subjects that we can say, and every single one of them had their own ingestion pipeline, as you can see, residing all the information to different DynamoDB tables. For rolling back this data, we can. Why should we roll back? Not just because TSC was going to roll back the entire application. Here we are saying that because of the business continuity and the disaster recovery that we had the requirement that we have for that. All the information should flow into TSC because TSC, as I'm going to show you in a moment, is the disaster recovery side. And then we use DynamoDB streams, we use Kinesis, we use application used to everything that we do inside the application is logged, and this log must also be taken to data center, TSC's data center. And this is the thing that kept going most live. So we using the app and all the information was flowing back into TSC. DynamoDB scaling is the challenge number 2. DynamoDB scaling is awesome, but it's not instantaneous. So for the workload characteristic, they had spikes. They have really, really short windows of time where we should be scaled up, and automatic scaling is not an option in this case. So we took the customer's requirement, and then we prepared the architecture to support that. So as you can see, we had data exchange on both sides, and we have a standard, static, scaled, reserved Amazon DynamoDB RCU and WCU for that case. Regarding disaster recovery, here we have a really strong requirement of data residency. So TSC debated internally a lot, and they decided to follow this path. The path is we have 2 AWS regions. The main region is the SAE, São Paulo region, and there is a disaster recovery region where we should not put data in that region. The data should only traffic was allowed, but not to rest any Brazilian citizen information outside Brazil. So we had this, and this region, this disaster recovery region, it used to be the edge of the TSC's environment. So if we let, in case of a disaster, if we let TSC's infrastructure with no edge protection, they would fall as well. So that's the reason why we did this. That's the reason why we do that. So how about security? Now you're going to have my fellow Andrea.
Hi, everyone. You can hear me? Yes? My name is Andrea Gouveia. I'm a principal consulting architect in ProServer Brazil. I had the opportunity to work in both projects and the Volt Resulting and e-Título. And I let you start. I don't know it's the word. Okay, thank you. Let's start for security design in the project. As you can see, this architect, the project is very simple. No, but you have been designing support for large and the of access security way. Let's start to talk about foundation of the project. Many times when the client starts the project and forget foundation, it's the principal security issue in the all critical projects. No. If you have preview using AWS, you as minding have using account testing, development, and the launch workloads in the same account. It's the first problems in all critical projects. No. When begin your journey using cloud adoption in AWS, you need to start the right foundation. The right foundation is very important. This includes following the well-architect framework, because well-architect framework provide the best practices for current recommendation organization. But maybe you ask me, but why I need landing zone? How much it's the landing zone project? How long time I need for implementation landing zone? I don't know, it's the... You can help me here? Yes? I need to change this now, okay. Okay. How long time I need for implementing landing zone? It's no problems if you start in the landing zone in extend account. It's they have do you have the scripts? The AWS provide the scripts for both cases. If you have a new account or if you had existing account. In this case, TSA have the simple architecture. Of course, the client have another accounts, production accounts, developer accounts, sandbox accounts, but it's the simple architecture for manager. TSA manager because it's the TSA accounting manager for pay and the administration for another accounts, audit, log, archiving, and security archiving. In this case, it's very important because TSA logging all steps for the application. And you have 3 more security steps for here. And network. But it's more. I need more security in my projects. Of course, it's the critical projects do you have. Can anyone help me about the topic? Okay. I have WAF, I have Advanced Shield, I have the load balance, I have CloudFront, I have Security Hub. It's all services in using the projects. But it's the big issue in security in big projects, it's the code review. The code review, it's the principal security issue in all projects. It's not the projects, but all projects use AWS. AWS have the service AWS Cloud Guru, and they have another tools with the partners. It's the choose all tools, it's not important. Deploying the test. It's the very specific test because it's the client have the provisional text with inside the client and another company another company, it's the architecture. Tests in all forms have the Binka route, with the region, outside the region, a specific test for the database, a specific test for application, a specific test, for example, use S3, because it's infrastructure, AWS have the limits, soft limits and the hard limits. This is important point when they start the test. You have the following, the steps for this. For example, deploy, fine-tuning, load test, measure, analysis, and development changes. In development changes, I think I need to test for only stress tests and security point. Critical success factor. It's the big project have the big team and the big infrastructure. No? In this case, the client will work with the internal team, its solution architecture, and the processor team, and another partners. For example, Embratel team work together in the client, it's the all steps. Serpro, it's another client, another partner works the project, but all steps have prof concepts. Because, for example, in this case, after prof concepts, architecture changes 7 times, because they have the new channels for the projects. We archivement and the finishing in a title, in this case, have the 0 incidation of day and 14 million certification issue and the 3.3 million absence justification. It's the first time it's the election in Brazil is working with the title. Maybe in the next election have the double numbers for this. No, it's the number, another infrastructure, another problems, and another issues for security in another architecture. But this is case, it's have this is number. Now it's the vote result.
Okay, so, hey everyone, good morning. My name is Vinicius Batista. I am a senior partner solutions architect at AWS. And now let's switch a little bit to how did we handle the content, actually the results distribution for reaching up to 1.5 million requests per second, right? And so just to keep the context fresh in your minds before we start, so as Kleber mentioned, during the election days, the D-days, as I'd like to say, we do have the voting hours from 8 a.m. to 5 p.m. at Brazilian time, which is when the people go to the voting stations and input their data and so on, right? And after that, after 5 p.m., the voting machines are closed and the data is sent to the customer, to the superior electoral court. And using their on-premises stack, they process all of that data. And by process, I mean validating the votes and counting that, aggregating that, and so on, right? And after this result is aggregated, and they need to publish it somewhere because basically the entire population wants to know about the election results, right? And for that, they counted on us on AWS for the first time in almost 20 years, I would say, right? And here I have a quick history on about the growth of the number of requests and the broadband used by our customer throughout the years. So they started up in 2010 with like 2.1 gigabits per second up to 86.4 in 2020. And this 2020 number is very important, right? Because that was the baseline for the 2022 elections. So based on these numbers, they created the initial set of requirements for last year's elections. And what are those numbers? So basically, we are speaking about 500K requests per second, right? And 150K result files. So as soon as the customer, as TSC, processed those files, they published it on our platform. And those are basically clear text JSON files, right? And these files are consumed not only by the end users using the official results application, but also by media stations, by TV stations, sorry, media outlets, and so on. So it's accessed literally hundreds of thousands of times per second, right? And of course, the customer, there is this peak time that we call, it's like after 5 p.m. up to 9 p.m. or 9:30 p.m. usually, that's the peak window for the content distribution. So they wanted, of course, to have like 100% availability, no downtimes, no any kind of security or issues that might damage the reputation of the elections, right? And so doing a technical deep dive on that, how did we implement this solution? So basically, we created an architecture based mostly on serverless services, right? And we also have so the other remaining services are all managed, especially, I'll talk a little bit about OpenSearch in a few seconds. But how this architecture works, how the solution works, right? So when the customer processes a file and made that available, they want to push that to AWS. We could do that by using like data sync or any kind of solution. However, the customer was already using a lot rsync. So they have used we set up a VPN, a site-to-site VPN, in order to provide the required security for this. And when the customer creates a file, they need to send it back to AWS. And so in this case, they are using rsync to push those files, right? And as soon as that file arrives into Amazon S3, our object storage, then due to the tight integration, the existing tight integration between S3 and Amazon Lambda, we are able to trigger an Amazon Lambda execution, right? So there is that Lambda function over there, and its role is basically to copy that file from this initial bucket to a second one. It just copies the file, right? Doesn't change the content, anything like that. And why that? Because this second bucket is the actual source or the actual origin for our CloudFront, Amazon CloudFront, right? So Amazon CloudFront is our content distribution network, and that's the entrance door, that's the front door for the entire population. So that's the public door for that. And of course, also we do have like AWS Shield Advanced that we'll talk about in a few minutes to provide advanced security against both network and application levels. And also there is Amazon Route 53 managing the DNS stuff inside the customer and inside the solution, right? And last but not least, I would like to give some moment to talk about OpenSearch service, right? So AWS, along with our partner Embratel, they have developed a single pane of glass containing all the data regarding this solution. And by all the data, I mean like data about the files which are arriving, right? So what time a given file has been received at AWS, what time has it been copied, and so on. And also, we were collecting data about the access being performed by the users, right? So where does this request come from? Is there any suspicious activity in terms of security? What is the broadband provider which this connection is coming from, and so on. And all of that because the customer wanted a single pane of glass to have all this data available, and if required, take any measure or any action, based in real-time data. So that provided a lot of confidence to the customer at an operation level, at an observability level. And so it's definitely a recommendation to have such kind of solution when you are dealing with a large-scale project like this one, right? However, what if we had like an extremely unlikely event of the region losing the connection to the public internet? So the solution has been deployed to São Paulo's region, so SA East 1. So what if this this region lost the connectivity, right? So in this case, as we are using this set of serverless services and managed services, etc., it was quite easy to actually deploy that in a secondary region, right? That I call here a contingency region, and deploy that. And keep that in standby mode. I mean, those services were not in the secondary region, were not processing data or receiving data at all, right? So in the unlikely case of something goes wrong in São Paulo, we could simply switch through Amazon Route 53 by, for example, using a health check. We could detect this incident and switch all the traffic to this secondary region, right? And as the customer as the solution was not processing data at all, and in the end of the day, they didn't execute anything over there because everything went smoothly in São Paulo. But basically, they pay very, very little money in order to have this contingency available in a secondary region, right? And well, everything looks good, sounds good. However, certainly there was a bunch of challenges here, right? And I want to highlight one special challenge we had concerning Amazon's S3 service limits, right? Because as everybody might know here, S3 has a limit in the number of requests it can process per second per prefix, right? And this number is 5,500 requests per second in the case of reading. That's the important one in this context, right? For writing, it's like 3,500, but we wrote very few at very few moments. However, as I mentioned previously, the customer wanted to grant at least a 500K request per second. And despite we have CloudFront here, the customer also wanted to keep the caching, the time to leave of the cache at the bare minimum level. And by bare minimum level, I cannot disclose the number here, but it's basically, you can assume it's like a single digit TTL, right? So how did we solve that? And in order to answer this question, it's important to understand some concepts around Amazon S3, right? So it's an object storage, and all of the files are treated as objects, of course, over there. And in order to organize our files or objects, in this case, we rely on what we call prefixes, right? So in the example behind me, you can see there is this orange part in the path of a given object. Everything in orange is the prefix, right? And why did you use that? Because, as you might know, S3 as an object storage is a little bit different from a traditional file system, right? We don't have like a hierarchy of directories and so on. But in this case, Amazon S3 uses that in order to organize the files, in order to sort those files and provide access to those files and so on, right? And the most important point here, as I mentioned, the throughput is based on the prefix. So in our case, we can already see some static patterns, right, in terms of prefixing those objects, because we do have the bucket name over there, which the results bucket /br/ the file name. And you can see that we have the same over and over and over. However, that changes those two-letter code over there, like BR, AC, AP, and so on, is the state code in Brazil. So as we do have 27 states in our nation, we already have 27 different prefixes, right? So that should work like a charm. If I multiply 27 if I multiply 27 by 5,500, we would have a lot of requests per second. However, there are some cases which it does not apply in our case, because some files are accessed many, many more times than the others. So, for example, the first file in the table is the presidential file, the results for the presidential election. So in that case, this file is literally accessed more than 100,000 times per second throughout the entire election. So this current limit of 5,500 falls behind that by a lot. So in order to solve that, what did we do in order to overcome this challenge, right? In order to do that, we rely a lot on what we call partitioning. And you can think on partitioning at a very, very high level. Take this with a grain of salt. But you can think on partitioning as the way Amazon S3 allocates resources in terms of hardware and software to process the request, to handle the request for a certain file, or a certain object, or a certain prefix, you know? So it's basically, let's say, a measure for capacity. And by using this kind of entropy here, and I mention entropy here because literally I was injecting in my prefix a dynamically generated string. In this case, just for out of curiosity, this string, the result over there, is basically the MD5 hash that has been calculated from the original prefix, right? So I calculate the MD5 hash and put it in at the end of my prefix. And why that? Because Amazon S3 has the capability to automatically scan and understand the pattern, the access pattern to our object, so it can understand which file is being mostly requested, what are the prefixes which are being mostly requested, and so on. And based on that, it has the capability to automatically expand that in terms of partitions right now. So it provides more partitions, and with that we have their own capacity in each partition or each prefix, sub-prefix in this case, because it's being generated automatically under the hood. So if you open AWS console and try to check a partitioned bucket, you're not gonna see this 8A, 8AC, C6, and so on prefixes, right? It runs under the hood. And so going back to the subject, so S3 has this capability to automatically scale, and then with this kind of entropy generated and placed in the middle of that prefix, we have it's able to provide multiple wow, I missed the term now, sub prefixes, and each one with its own capacity, right? So and how did we handle that? How did we implement that, right? And before I answer that, I must advise you there is a gotcha over here, in this process. As I mentioned, S3 has the capability to escalate automatically, right? However, it might take up to 60 minutes to finish. So in some scenarios, your user in this meanwhile might receive a message like a 503 or a slowdown message. So in order to avoid that, as we didn't want that to happen, there is a process we can follow, everybody actually can follow, which is basically we got in touch with the service team and, through a support ticket in this case, and via an IAM as well, which I will talk in a few minutes. But we have requested the team to pre-partition this bucket, right? So you already have the pattern, the access pattern. We already have the way we are going to generate those dynamic hashing stuff and so on. And based on that, they pre-generated, pre-populated the bucket, not the bucket, but they provisioned the internal infrastructure in order to handle that. So at the real time, at 5 p.m. local time, people didn't see any kind of issues, right? However, as I said, this is a very specific point, and if you need to, oh, I have something similar to that, how can I do that? So get in touch with your account SA, or partner SA if you are a partner, or even open a ticket through our support, and then we definitely can help you to understand and handle that, and if required, perform this pre-partitioning stuff, right? So how did we implement that? From a technical perspective, it was quite simple because we already had the results bucket, which is where the data arrives from the customer. when we copy the file to the second bucket, we are actually using that Lambda function not only to copy the data, but also to calculate the MD5 hash from the prefix of that file, right? So when we copy that, we already copy with the entire path, I would say, with the new prefix to the origin of our CloudFront distribution, right? However, when a user tries to access a file, makes a request, nobody knows about this, right? About hashing, prefix, and all of that stuff. So in this case, we handle that by basically doing a reverse engineering in our logic here. We reversed the logic and calculated the MD5 of a given request by using CloudFront function. For those who doesn't know about it, CloudFront function is a compute capacity available at our edge locations. It's able to execute very fast calculations, and this is a very good use case for CloudFront functions because it runs like almost instantly, right? It returns the hashing of that given string and moves and passes it to CloudFront with the correct, let's say, with the hash-based file or object path to CloudFront, that you handle that to S3 and so on. So this kind of implementation could definitely help you to scale up operations, right, in high-performance scenarios and so on. And besides that, I have a set of recommendations for you. As you might have noticed, Amazon S3 is massively scalable, right? We can scale that using like this partitioning stuff I just showed you. We can also improve the performance by using a specific kind of endpoint that better suits your needs. So we have like VPC endpoints, interface endpoints, public endpoints, private endpoints. So there's a lot of endpoints, and we can rely on that. There's certainly an endpoint that fits your use case, right? And of course, we could also parallelize operations, right? So if I want to send a big file up to S3, instead of sending that using a single-threaded work, we can like split that file into multiple smaller chunks and upload everything in parallel. That's what we call multi-party uploads. And in the other way, in order to request just a portion of a very big file which already lives in Amazon S3, we can use ranged gets, right? So those are also some other recommendations, and I definitely would like to invite you to have a look at Amazon S3 developer guide and implementation guide because it's really useful, right? So in order to distribute all of those files, as I mentioned, we are relying on Amazon CloudFront with a big network composed by more than 400 POPs or point of presence, right? Across 90 cities, 48 countries, and so on. And we use that in a very specific way because, as I mentioned, the customer wanted to keep the caching levels at a bare minimum. So we have used CloudFront mostly as a port of entry to AWS's private network. And what I mean by that, so the workloads were residing in São Paulo's region, but we have access from all over the globe. So if a user is in Japan, for example, and wants to access the results, instead of hopping that request through the public internet, the request, by using CloudFront, the request must basically enter the Amazon private backbone through a POP in Japan, and then move along using our high-performance network. I'm talking about fiber-based networks with low latency and high throughput. So it's much more reliable and much faster than relying on the traditional network. But also, the customer also used it, as I mentioned. That was not like a big deal because they were keeping that value really slow, but the most traditional, I would say, use case for a content distribution network is usually through cache, right? And so you can also use, we have also used some caching by relying on CloudFront, and it has this multi multi-layer, I would say, architecture, which is based on POPs, on edge caches, and then some regional, intermediate regional edge caches, and only if your file, if the content's not on any of those caches, then we will reach out the origin site, right? The origin infrastructure, actually. Okay, so in order to protect all of that infrastructure, we relied on AWS Shield Advanced. So Shield Advanced has two versions, right? So the first one, the Shield Standard, it provides out-of-the-box level 3 and level 4 protection for the AWS infrastructure. And if you already use AWS, you are already using AWS Shield Standard because it's enabled by default, and that's the default service we do use in order to protect our infra. And also, it has the, if you are using CloudFront, Elastic Load Balancing, Elastic IP, and other services, well, you definitely are a user of AWS Shield Standard. But besides that, we have also the AWS Shield Advanced, which on top of the standard version, it also adds capacity to protect the level 7 of our stack. So I'm talking here about application protection, right? So things like cross-site scripting, SQL injection, and others are protected by default when we are using Shield Advanced. And besides that, of course, we also provide the SRT, or Shield Response Team, which provides like a 24/7 team of experts that could help you not only to identify, but also mitigate any kind of threats. And there is also the cost protection. So if you are the victim of a DDoS attack and your infrastructure just goes up without scaling, you are protecting in terms of cost. I mean, you won't pay for that, right? And how did we validate that? So we perform validations in a set of 3 main pillars, so on both operational security and performance, right? And in terms of operations, I would like to emphasize, I cannot stress enough the importance of to have everything, this long-running project well organized, right? And so in order to use, AWS has this offering, the Amazon Infrastructure Event Management, or IEM as we call. And IEM is an offering already available for any user of enterprise support. It's available for free for who is using ES, but also it's available for business users, right? And it provides access to a team in our support to help you not only to understand the needs of your workload, but also help you documenting that, executing stuff like the well-architected review, which is very important, and also helping you to get in touch with service teams in order to handle capacity. So, for example, we just had the Black Friday here. That's an example of an event where our customers want to grant. We do have resources in terms of instance or whatever we do use available in my region, right? And IAM can help you to provide that. Also, it provides, it will stand by our side throughout the event execution. And after that, when the event is closed, it will help us to better understand what went fine, what could be better, and create a report with the best practices and suggestions for your next event, right? In terms of security, Andre already talked a little bit about the application layer security and the tests and stuff the customer did. And we also performed some volumetric tests in this realm, right? So basically distributed load testing and also the low and slow. So both of them, in different ways, they are trying to exhaust the resources of our edge infrastructure, right? And for those, we rely a lot. The first thing was the AWS distributed load testing solution. It's an open source solution which is available in AWS GitHub repo, right? And it works by deploying a stack which will basically handle all the provisioning and configuration usually required when you are running distributed load test. So not only the configuration of the masters and the agents, the workers, right? But also, it will decommission that infrastructure as soon as your test closes, as it finishes, right? And it's 100% with Apache's JMeter. So if you already work with JMeter, a lot of plugins, a lot of community support, you can definitely have a look in our DLT solution, right? As I mentioned, it's available in our GitHub repo. Also, if you plan to execute any kind of DDoS, being that a DLT or a low and slow kind of test, please take a time and have a look on that DDoS testing policy, because you are allowed to do that, no problems at all. However, there are certain limits and certain process that needs to be, certain criteria that needs to be met. So please have a look on that to avoid any kind of disruption to your workloads, right? And last but not least, we do also provide the best practices for DDoS resilience, right? Which provides ways to identify the most to improve actually the resilience against DDoS attacks by identifying the main vectors and how to identify and mitigate those, right? And so what were the final results on this entire journey concerning results distribution? So we basically executed or answered the 3 times more the initial requirements from the customer. We handled like 1.5 million requests per second, right? And over the course of 4 hours and 10 minutes, we distributed 90 terabytes of data. And you might think, oh, that's not a lot of data, right? I have a hard disk in my home server which handles like 100 terabytes. But if you assume that each request has an average size of like between 3 and 5 kilobytes of data, so that's a lot of requests, right? And all of that has been executed with 0 incidents, so no downtime, no issues in security, no any kind of issues. And that was the first time in almost 20 years that the customer had the results distribution without any kind of errors. And that was very recognized and something we worked hard in order to implement, right? And so doing a quick recap or wrap up on what we talked today. So what we have learned, so the first and most important, we should like have a planning and coordination in place and a lot of communication, right? Because in projects like this, we do have not only the AWS internal teams, but our partners at Embratel. We have also the services team, the customer team. So communication, planning, coordination, it's like it's a no-brainer, right? Test everything. Testing is important. If you need, be prepared to execute testings all the time, multiple times, sorry. If possible, you can use like the DLT solution I just mentioned, like a part of your CI or CD pipeline, right? Because with that, you're gonna have like a real data, real insights. Sorry, sir.
So how was the system load testing?
I'm sorry?
How was it load testing, stress testing?
How was?
How was the
Load testing, what do you do the load testing?
Oh yeah, we do. So we do. Thank you. So you asked just how do we do the load testing? And in this case, we run that like multiple times, like every week, basically. Let's say, let's put like that. And we increasingly over the time we increased the number of requests. Like in the first week, we run like a given number. It's not an exactly number, but like with 100,000 requests. And every major interaction in our architecture, we executed that again and again and again, always increasing that. And it looks like 3 hours, 2 to 3 hours. So basically, you're running multiple elections before the real election. You know. Did he answer your question?
So another thing is, what was the tool or the tools used to simulate the load?
Oh yeah. So the tools we have used this one. Let me go back here. Like this AWS distributed load testing solution, right? We developed our testing scripts using JMeter, Apache JMeter, right? And this tool is 100% compatible with JMeter. So you basically export your JMeter package, like your zip file containing the GMX and all the plugin configurations, and it runs that. Okay? So doing a quick recap. So test everything multiple times if required, and that data, that resulting data, will eventually lead us to change, and that's fine, right? So we need to make changes, and that's okay. And of course, study the customer requirements, know the service limits, and for that, you can count on us at AWS to not only to understand the limits, but also provide ways to answer or to provide a solution that meets your customer requirements, right? And before we finish, I would like to ask you to please complete the survey in the app, because your feedback is very important to us. And with that, please feel free to get in touch as well. And so thank you very much for your time. I really appreciate it, and have a nice day.